whatever. But we see right here, it's got a nice little curl now, and then there's the eruption, and it goes all the way downward. So yeah, we have a full-on eruption, and that is earthward. So that is coming towards Earth. It's going to be very hard to tell much on that due to contrast, the background being much hotter and sort of washing out our view of this filament. But this filament originally was one of my main concerns. And I'm like, it's not going to do anything because it kept growing and finding new connections to the surface of the sun. But apparently, I was wrong. Yeah. So this comes all the way down to here. And we're going to see it erupt. Let's look at this very closely. Right there. That's the eruption. Now, with the filament eruption, it's not very showy like with a flare. A flare, typically you have the very high frequency of the two coronal loops accidentally high-fiving, crossing their wires, and causing a microwave frequency to be shouted out at the crossing point, and higher intense frequencies then at the surface of the sun, and lower intense frequencies or longer waves further away from the sun. So we end up with a flare that typically shows us a very beautiful presentation, and then sometimes we can see a CME very clearly as the cooler plasma disperses above it as this sort of hazy cloud. But in this situation, that is not as clear, but I can play with the imagery a little bit and see if I can highlight some of this moving plasma. Indeed, I make a lot of analysis and assertions of this based upon my understanding of the situations, but they don't always come to fruition. The idea behind it is anything is possible, but knowing the potential is the key. So being wrong is actually a wonderful thing because it means we learn more. But knowing the potential is the crucial part, knowing what it can do so that we know what to look for. And this is one of the things even after I said, yeah, it looks like it's not going to happen, and that was yesterday, I think, that my expectations for this filament was wrong, and it turns out that was wrong, and I was right. That makes sense. Yeah, I had to do a system reboot due to a major change to my software on my computer. There's been some certain systems software has become less reliable, and I wanted to remove it before it caused a conflict. So the time frame of being down was 2.1 seconds longer than it would have been to maintain my connection. Fortunately, rebooting the computer's fast, so typically I can reboot the computer and no one would know, but I couldn't do it quite fast enough with the amount of changes I made. All right, here we go. So we can clearly see the filament here, right here. This is already on the move, but it hasn't done a full-on push from the eruption just yet. And looking at it here, we can see very clearly it is coming outward, very Earth directed here. It's got a full spread. You can see it's pushed. It's got a nice bow as well, so we're going to get a spiral to this, meaning that it could make it difficult to assess the full-on polarity, but I doubt that would be difficult for people like Dr. Tamita Scott. She'll probably know this one right away. Yeah, but if you look really closely, you'll see a major impact here from this dimming region, and that's the telltale sign. That's how I knew something had happened. And you'll see that darkened spot where it gets dark. That is the corona being cleared with as this plasma pushes out. And what we have is a cooler plasma being displayed, as the surface of the sun is much cooler than above the sun and below the sun surface. So the corona is typically hotter than the surface, always actually. And what we have is when the corona is displaced, we see that colder plasma in clear display. And that's where we get our corona holes. A corona hole is not a hole in the surface of the sun. It's a hole in the corona, which is like the sky. And it's not necessarily a hole. It's a clear space, much like having a clear sky. And we just hit G2 levels, by the way. Let's take a look at our K indices. I don't see an escalation on the reading here, so my guess is there will be an update soon with this. Yeah, about time for an update on that. All right, but yeah, so we have this right here will be coming towards Earth. This will be a storm causing solar storm, space weather as it were. And it's going to look tremendous, yes, on Soho Lasco. And being this just happened, it's going to be fun to watch. Yeah, this is yeah. So let's go back to 171 angstroms. Let me change my imagery back to default on here so we can get better clarity for overall imagery. All right, now that we know what we're looking for, it could be easier to follow on the other angstroms. And this right here, all right. So right here, this is our prominent or a filament, and you can see how it seems to be extending, and it does. It connects to this part right here, has more connections, and then it goes, and you see that large, massive dimming area. So what happened is, as it kept growing and extending, I assumed that it was solidifying its footing in the ground, as it were, being that it was actually the feet. It has a foot point, and that's what it's called when the magnetic field line, or a coronal loop, the point that crosses into the surface of the sun into the photosphere to hold on to its grasp to where it is naturally, is called a foot point. So all that for the silly pun, sorry. But yeah, so here we see it just before. It's just connecting to its bottom portion. And as we continue a little bit slower this time, we can see, there we go. motion happening here. There's a small eruption here. This might be one of the precursors to this, the origin, the most basis point where this filament had its strongest foothold, as it were, right here. And then we're going to see it start to extend some more, and this is when I finally say yesterday, doesn't look like it's going to happen because it's grown and extended itself with more connection, but then we have liftoff. We already see some of the motion outward. This filament's moving more to the right. That's actually an illusion somewhat. It's moving up, and as it rotates, it gets a little easier to see its placement. Anyhow, and then there it is. And this entire stretch, this dimming area, is the span of this eruption. So you can imagine this is going to be a very fun storm to endure when it reaches Earth. Now, its speed at going is going to be difficult to decipher due to its nature of how it erupted with the hotter plasma behind it, so I can't see its full dispersal. I do know for a fact that Earth is in the trajectory, this is in the strike zone, but it's going to be until LASCO has beautiful imagery for us that I can be able to decipher its speed and approximate arrival time. So this, we're talking hours out before I know much more than that. And we can see the expansion of the dimming region. This is due to that shock wave, as it were, pushing all the clouds of the corona side to the side, and we see this darker area, which is the surface of the sun, being cooler plasma. And then we see the clouds start to roll back in. So yeah, we have right here an absolutely beautiful display of how no matter how much you know or expect or are certain of something to happen, it's completely impossible to be completely right. That's the beauty of science. It's a tool, not a religion. So it's based upon constantly improving, learning, and understanding. And here we see that the sun has something, a surprise in store, where we see this smaller filament, which was significant in its own, more than double in size in the span of 48 hours, and then erupt. That is a beautiful eruption too. Looking at 193 angstroms might be a little bit better because we'll see a little better of the dimming region, which shows us, with 193, shows us the corona more specifically, and it blacks out the deepest points of the corona as the cooler plasma, so its spectrum view is slightly different, so we can see just how impacted the corona was from the significance of this filament eruption, which we see here. Get a little more definition of what the filament looked like, as it were. It covered some of this plasma area here, and then as it goes, we can see the dimming region is quite large. Sorry for the flashing. That's due to either lost imagery during segments, or they did a close-up picture where they zoomed into an area, and they've been very interested in region 3071. They do that periodically when they see a region that's changing or altering or has a slightly different path, so they can do basically what I'm doing, where they analyze it to see where the sun is in its cycle, what to expect next, and things of that nature. But here's the overall filament is just straight up and down, but there is some connectivity to this area here. So here's the filament. It keeps making connections, You can see how it starts to straighten out slightly. And then the burst. Yeah, that is a beautiful eruption. And as it cleared down to the corona, that area, there is a heightened chance that that caused some of the solar wind particles to also come to play at this, which means that it could be slightly accelerated along from its own power of the eruption. So it could be possible that this could arrive in a slightly faster condition than typical. So preliminary analysis, I'm going to have to say this is going to be 36 hours to 4 days. I mean, it's impossible to know just yet until we get those LASCO images.